In the previous video, we looked at this example in which when the speed of the car increased, the time taken by it to reach the finish line decreased. Let's erase this and understand this with numbers. Let's say the distance to the finish line is 60 kilometers. Before we move on to the understanding of time and speed, let me quickly show you the best way to understand the formulae for time, distance, and speed. We draw a triangle like this. Write a T inside and divide it into 3 parts. We write D on top and S and T at the bottom. The letters D, S, and T stand for distance, speed, and time. You should just remember that D should be on top. S and T can be interchanged at the bottom. It doesn't matter. So using the triangle, if we have to find distance, we multiply speed with time. So D is equal to S multiplied by T. If we want to find T, it is D by S. Hence D is written on top and S is written underneath. And similarly, if you want to find speed, it is D divided by T. We will use this formula in our example. Let's erase this and write the formula time is equal to distance by speed. Let's make 3 columns to understand what indirect variation actually is. Let the speed be x, the time be y, and since the distance is constant, let it be k. We form a table of speed, distance, and time. Also assume that speed is in kilometers per hour and time is in hours. We will consider the 4 cases we saw. When the car travels slow, at a normal speed, fast, and super fast. And in all cases, the distance is constant at 60 kilometers. In the first case, assume that the speed was 5 kilometers per hour. The time taken will be distance divided by speed, that is 60 by 5, which gives us 12 hours. So this is read as if the car has to travel 60 kilometers at the speed of 5 kilometers per hour, it will take 12 hours to reach the finish line. In the second case, the car travels at a slightly faster speed, around 10 kilometers per hour. It's faster than in the first case, so the time taken will be 60 divided by 10, which equals 6 hours. And in the third case, the speed is 20 kilometers per hour. We get the time as 60 by 20, 3 hours. And in the last case, if the super fast speed is 30 kilometers per hour, we get the time taken as 60 by 30, which is 2 hours. Now let us analyze any 2 scenarios at a time. We observe the first and the second columns first. That is, we just observe the speed and the time in each case. In the first and the second case, if we multiply the speed by 2, we divide the time by 2. 5 multiplied by 2 is 10 and 12 divided by 2 is 6. In the second and the third cases, when we multiply the speed by 2, we divide the time by 2. When this was scaled up by a factor, this was scaled down by the same factor. Scaled up means multiplied and scaled down means divided. Similarly, in the second and the fourth cases, when we multiply the speed by 3, we divide the time taken by 3. So when speed is scaled up by a factor, the time taken will be scaled down by the same factor. That is indirect variation. But how do we say that indirect variation exists between these 2? We can say that time varies inversely with speed. We call it inverse because if it's a multiplication here, it results in a division here. Also notice that if time is multiplied by a factor, the speed is divided by the same factor. For example, 6 multiplied by 2 is 12 and 10 divided by 2 is 5. So we can also say that speed varies inversely with time. They both mean the same thing. we can see that the product of speed and time is constant in every case. 5 times 12 is 60, 10 times 6 is 60, and so on. Hence, in indirect variation, we say that the product of x and y is constant. It is more commonly written as xy is equal to k, where k is the constant.